at our warm-up. And let's hope that this comes on. So again, for the function to be continuous, we have to have the function is defined. We have to have the left and right hand limit equal each other, and that gives us the overall limit. And then our function defined is the limit. This is what we just earlier did. Okay. All right, so our first one just simply asks if the function is continuous at x equal to 3. I don't know what's happening over there. All right, so again, we need to go through the 3 things whenever we're talking about that continuity, and it is extremely important that you show each of these.
He's having a great time.
Do we know who that is that no cross there, or is it over there?
It's right here.
Oh my god, conflicting answers. No. Okay, so my first thing, do we have f of 3? Yes. What chunk do I need to use for f of 3? Okay, 10x minus 1. So I have 10 times 3 minus 1, and what do we get? Be careful here. Do not write the following. F of x is not simply just equal 21. F of x is this crazy thing. Also, do not write the following. That is also f of 3 is not 10x minus 1. F of 3 is 29. Okay, so make sure you have proper notation. When I'm putting in that 3 for x, I should no longer see that. Okay. So we have the function is defined. Man, I just made you run out here all the time. Thank you. Alright. Now, secondly, I need to check that my overall limit exists. But we're working with a piecewise function, so I don't just get to do one limit, I have to do left, and I have to do right. This does take some time, but it's what's necessary to truly check that it is continuous. So I need to check that my left-hand limit is that equal to my right-hand limit. So we talked about how you can set this up a little bit different. We've done before where we found our left hand, and then far over here we found our right hand, and then decided whether or not they were equal. I'm going to kind of work through it step by step. I put that question mark because I don't know that they're equal. That's what I'm checking. Now with piecewise, I do have to specify which of these 3 pieces I'm working with. So when I do my left-hand limit, which of the 3 am I going to use? The top one, good, because this is x is less than 3, which is coming from the left of 3. So you have to specify that that is the piece that you are using. Alright? And we're checking again if that equals the right-hand side. So what's going to be the right-hand piece that I use? The bottom one, which is a just fancy old thing. Alright. So again, you have to specify which piece with the piecewise function. Now, there are some instances in which I don't have a different function for the left and the right. An example of that would be...
Then you just do the one without the plus and minus.
Yeah, you would just do the overall limit, that's right. So an example would be if I had x minus 4 over x plus 3, when x does not equal negative 3. And second one x does equal negative. In this case, looking at negative 3, my left-hand limit and my right-hand limit use that same function. So in this case, I could just go ahead and do my overall limit because it's the same function I'm using. But over here, I have different functions for left and right, so I have to show the different left and right. Do we see that? Do we have questions on that? Okay. So if it's a different function coming from the left and from the right, my piecewise, then I've got to go ahead and specify those pieces. All right. Can I do direct substitution for this left-hand one? Yeah. Let's just we're checking to see, what's my limit over here? 30. Alright, what do we get on the left side when we simplify? Oh, how nice! 30 equals 30. So I did all that to decide what? What can I say? Yeah, the overall limit as x approaches 3 of f of x is 30. Okay? Yes.
Can you not accept the first equation equal to the second one at x equals 3?
The reason why we're allowed to do that is because in my definition it requests the limit. So what you're doing there is just the algebra down here, but we do have to show that it's, the reason why we know that is because of the limit. So you do need to write out that limit notation, mainly because the definition says the limit exists, so that's what to check. Now what you're doing is mentally, you're like, oh, well I know that means that I check this equation, but why is that the case? Because of other questions so far? Yes.
Do we always have to include the question mark when we're...
If we're checking, yeah. Because otherwise we don't know that they're equal. The other thing you could do is if at the end you find they're not equal, then just go back up and slash it. That would be fine. But just to be safe, just go. Yes.
So if you're going through and you find out that one of the things doesn't work,
nope. Then you can go and say therefore not continuous. Show what the issue is. So like if here we had they weren't the same, then you would say limit does not exist, therefore not continuous.
So if you know that that's going to be the case, do you even have to do the first one?
Nah, you can just jump straight to that. Yeah. Yeah. So if you see that step 2 is going to be the issue, go ahead and do that. Don't worry about step 1. Other questions before you continue? Okay. So then my third thing was that they are equal. So f of 3, does this equal the limit as x approaches 3 of f of x? No. Big issue there. So now, because those are not equal, then I can say f of x is not continuous. At x equal to 3. Okay, so again, I see from up here f of 3 is 29. I see from here the limit is 30. Those are not the same. So just gets disqualified in step 3. So therefore my function is not continuous. Please make sure we're working on our notation. I'm still seeing issues where we're not writing the function there. We're just saying limit equals. Or once we've taken the limit, for example right here in this step, we're still writing the limit notation even though we've evaluated the limit. Remember, once you plug in or use a rule, we have evaluated the limit. Okay, questions on that? Alright, so get continuity, extremely important. I know we keep doing it, but it's good for you. Alright, so then our next one said, for what value of k is the function continuous at x equal to 4? So again, think of your continuity definition. To know if it is continuous, we need to have that the function is defined. Looking at my piecewise, do I have the function is defined? Yeah. Okay, so, and we're trying to find k to make it continuous. So k is not within that piece that has it defined, so that's not really going to do much for us. But then my second piece is that the limit has to exist. Again, piecewise function, 2 different functions here. I need to make sure my left-hand limit and the right-hand limit are the same. We want that to be the same, so then whatever k value makes those the same at x equal to 4, that's what we want k to be. Now, when we did this before, we would write out this notation, 3x squared. We would say, all right, well, we want this guy to equal this guy. We want this specifically at x equal to 4. Now, you must specify where it is that we're looking at. If you just say that those are equal, that's not the case. We want them to be equal specifically at x. A lot of us are forgetting that notation. So from here on out, I'm going to go ahead and do it thinking back to my continuity definition in hopes that that'll help us kind of remember that piece. So again, my continuity definition, step 2, says that my left-hand limit, so what we want is for my left-hand limit, we're looking at 4, to equal that right-hand limit. And you see it has that piece of looking at 4 included in there. Okay, this is probably more mathematically sound. If you did it the other way, that's fine, but you must have, we want it at x equals 4. But this kind of includes that in it. So we want my left-hand limit and my right-hand limit to be the same. That'll ensure that these match up. There's no holes or jumps that creates that discontinuity. Okay, now again, piecewise functions, we have to specify which piece we're working with. So I want my left-hand limit, which is this guy, using that top one. So 3x squared to equal my right-hand limit, which we're going to be using that bottom piece. I know some of us also struggled with knowing what to do when we were sending equals, so hopefully this helps out with that. And now can I go ahead and do direct substitution here? Yeah. Take your 4, put it in. 3 times 4 squared minus 11 times 4 minus 4. And can I do direct substitution over here? Yeah. Now, k is some unknown constant. We're trying to find that. So we're not putting it in for k, we're putting it in for x. X becomes 4. So I have k times 4 squared minus 2 times 4 minus 4. Okay. What did we get on the left side? 0. Do we agree? Oddly enough, that is true. And then over here, 16k minus 9. What you guys got? Okay. So again, we're going to go ahead and proceed by using that notation. In order for it to be continuous, we know the left and right hand limits need to be the same. So we're going to be looking at using that to help us out. Now, when we solve for k, we get k equals 9/16. Do we agree? Again, AP, you need to see the piece that you're using. Now, I will say I've seen on some of the AP scorings that they include that you must first specify the limit of the function and then specify the piece. And other times they haven't required you to specify f of x, so you can go straight to this part here where you use the piece. For me, if that's the only function that we're working with in that problem, then I'm fine with you jumping straight to here. The issue comes in when there's more than one function. I need to know which function you're referring to in the first place. But if that's the only function, I'm fine with you just going ahead and jumping straight to your pieces and then simplifying from there. Okay. Questions on what we did with this? So if k is 9/16, then we have these two match up specifically at x. Now, just in case you didn't believe me, I looked up AP questions on continuity. So give me a moment to bring that up. So first we have one in 2011, which earlier today I learned meant you guys were still in elementary school. You guys were born in 2000? Okay. So this was in 2011, which I thought wasn't that long ago. For me, it wasn't that long ago. And it says, let f be this function, yada yada. We see piecewise. And part A says, show that f is continuous at x equal to 0. Again, you've got to have those three pieces. Your function exists at that point. The limit exists at that point, which piecewise means we check left and right, and that those two are equal. If we take a look at the grading rubric for this, let's get rid of that. Yeah. Mm-hmm. Come on, go ahead. Okay. So we can see for our continuity, again, they have that piece. All right, we have this piece where my function is defined. They say what that is. We have my left-hand limit that they show. We have our right-hand limit that they show. And again, you can see that they specify which piece of the function we're working with. Okay? You've got to have all those And then we can go ahead and say our overall limit equals f in the end. Therefore, f is continuous. So again, you have to have those pieces, and I will continue to be very strict with those pieces. Your notation's got to be proper for that as well. And then in 2012, which I think you guys might have still been in elementary school at that point, I was finishing college. So in 2012, they had another problem dealing with continuity. Were you guys still in elementary school? Middle school? Hey, you made it to middle school at that point. Woo! Alright, so in 2012 for part C, they give us g of x, and then it says, is g continuous at x equal to 3? And again, you've got to justify all that. Now notice that here, we're dealing with multiple different functions, so you'll see for their answer that they did start off by specifying we're doing the limit of g of x. Let me try zooming in a bit here. Yikes, not that much. Okay. So again, we see that they found whether or not the function was defined at that point. That's what we do for step 1. And then they considered their left hand and their right hand limits, because it is again a piecewise function. Notice they specified what function they were doing the limit of, and then broke it into the pieces, again, because we have more than one function happening within our problem. And then they say what their overall limit is, and then our big punchline, so this is our step 2. Our big punchline is that the limit equals the function value, therefore it is continuous. You can see it's a long process, but that is what's necessary to show something is continuous. We have to go through those 3 requirements of the definition of continuity. Okay, so I'm not lying to you, at least not about this. Questions on all that? Okay. Go ahead and pull out your notes from last class. I want to do just, I think, one more problem with the differentiability. A little bit more review with that. So we're going to use this piecewise function. And with this one, we're going to just check to see, is f of x differentiable at 1? Is f of x differentiable? Okay, so again, we're working with the piecewise function. We know how to take derivatives of piecewise. But we need to first check, is my original function continuous, and is my derivative continuous? Alright, so let's start off by looking at f of x. Alright, so first of all, do I have f of 1? Yes. Top function or bottom function? Top, good. And we get 1. Do we agree with that? Now, secondly, got to take a look at my limits. Limit as x approaches 1 from the left. And again, specify which piece you're talking about. So I'm talking about from the left, so I'm going to say 2 minus x. And I'm going to go ahead and evaluate that in a different way. That's more right. Alright, so can I do direct substitution here? Yep, great. 2 minus 1, which is 1. I'm going to leave a gap to decide if it's equal or not equal to the right hand. Limit as x approaches 1 from the right. And I'm going to use my bottom piece for this because we're coming from the right. It's greater than that. X squared minus 2x plus 2. Okay. Now I take those values and put it in, I get 1 minus 2 plus 2. So are those equal? Yeah. Nice, equal, so I can go ahead and say my overall limit is 1. Okay, so again, just formatting here. Instead of working down, I kind of worked across to show that they were equal. Either way is fine. Alright, and then finally, does f of 1 equal my limit as x approaches 1? Yeah. So we can go and say that my original function is continuous. X equals 1. so that gives us the green light to go ahead and check if the derivative is continuous. Alright, so let's go ahead and take our derivative. Again, we take the derivative of each piece. What's the derivative of my first piece? -1. But we cannot have that or equal to yet. We'll leave it not there for now. And then what's my derivative of the bottom piece? Here, 2x minus 2. Alright. We aren't sure if it's defined, right? We're not sure if we can put in that or equal to. So let's check that left and right. You guys go ahead and check left and right, see what you get for that. Okay. How many of you were trying to listen for this? Oh, good. Okay, so we need to check our left and right hand behavior, not behavior, left and right hand limits. Did we get them to work? That's unfortunate. Alright, so we're taking the limit of my derivative. I feel like I should go ahead and specify, since we're now kind of using two different functions, I'm going to go ahead and specify that we're working with the derivative here. X approaches 1 from the left of -1. And we're checking this, right? So I don't know that they're equal. I need to put that question mark. I need to indicate that I don't know that they're equal. That's what I'm checking to see. My limit is x approaches 1 from the right, 2x minus 2. Are we good there?
Oh, not yet.
Is anyone, or did we do something like that? Take this and put it in, we get -1. Just wondering. If I take 1 and put it over here, what do I get? Yikes, not the same. In fact, you can go back up and slash each of those. So this indicates to me that the left-hand limit and my right-hand limit of my derivative are not the same, which means it's not going to be continuous at that point, right? So we have then my derivative is not continuous at x equal to 1, was it? So from there, I'm going to say my original function is not differentiable at x equal to 1. Okay, because we were checking to see if my original function is differentiable. In order for that to be the case, the original function must be continuous and my derivative must be continuous. Questions on that? Did we get that? Raise your hand if you got this. Okay. Other questions with that? Alright. That's clear. Oh, sorry. F of x is not different. We know that because my derivative is not continuous with x. Other questions on that? Yes. F of x is continuous. Yeah, it's just its derivative is not, so it can't be, the original can't be different. Other questions with this? Okay.